This tutorial will show you how to solve different right triangles using the graphical calculator. First note I want to make sure everyone understands that in order to do these exercises, your calculator must be in degree mode. I showed you how to do that before, but as a review, in order to do that, you hit Mode button, and notice you have settings. You want to arrow down where it says radian or degree, arrow over the degree, hit Enter, make sure you're in degree mode. Hit second quit to come out of it. Now, there's a couple different types of right triangles we're going to use to solve. We either are going to have an angle and a side, or possibly two sides. The angle and the side, there's one here and one here. We're simply going to use our fundamental identities. If you have a triangle that has two sides and no angle, we're going to have to use an inverse trig function. So not only am I going to show you how to do inverse trig functions on here, but we're going to use them to solve a right triangle. So the first one, when you're solving a right triangle as I described in class, we want to find all three sides and all three angles. Okay? In the first example, where they give us one of the angles, I can find the third angle here by simply taking 180, subtracting 90, which is the right angle, and then subtracting the given angle of 24. So we get 90 minus 24, which equals 66 degrees. Okay, so this angle here is 66 degrees. Now, to find the missing side, since I have one angle on one side, I can use one of my trig identities. We're calling this A and calling this B. Okay, I'm going to find B, but in this case, we can say the sine of B, or sine of 24, is equal to opposite, which is B, over hypotenuse, which is 8. Or 8 times sine of 24 is equal to B. Plug that in my calculator. This is why we have to be in degree mode. So we can take sine of 24 times 8. It's 3 point, round it to two digits, 3.25. Now, I either can use a second trig function if I want to find A, or since I have two of the sides, I can use my Pythagorean theorem and say 8 squared equals 3.25 squared plus, in this case, A squared, and solve for A. 64 equals 10 point round it 5/6 plus B plus A squared. So we get 64 minus 10.56 equals 53.44 equals A squared. We're going to have to take the square root of that. .31 approximately is what A equals. Approximately A. So my sides are 7.31, 3.25, and 8. And my angles are 90, 66, and 24. Second example, we have to call this theta. I'm going to have to find theta. Okay, I don't only have one angle, so I can't find all three angles yet. But I do have two sides. So we're going to have to use the inverse trig function. In this case, tangent of theta, which we're looking for, is opposite over adjacent, 5/7. Do that on the calculator. 5 divided by 7. Approximately, we're going to keep it that way. In order to find theta, we're going to have to use the inverse trig function. Theta equals arctan, or tangent inverse, of 5/7. Now, I called it arctan in class. There's no arctan on your calculator. Tangent inverse is the second of the tangent button. So, what we're going to do, I'm going to do this all together. I'm going to clear this out, do second tangent, there's your tangent inverse, of 5 divided by 7, close parentheses, hit enter. Being that I'm in degree mode, it's going to give me my answer in degrees. That's why we need to be in degree mode. So theta is approximately, round it, 35.5 degrees. Okay, I can find this angle here by taking 180, call this A, 180 minus 90 minus 35.5. Okay, let's do this to be exact in the calculator. We'll get 90 minus 35.5 is 54.5. To find the adjacent hypotenuse C, since I have two sides, I again can use the Pythagorean theorem. Second square root of 25 plus 49, 8.6, approximately 8.6. Third example, again, it's like example 1, but different values. Okay. Angle 49 degrees. I give you one of the sides, but the side I gave you, okay, is not for sine or cosine. You're gonna have to use the reciprocal of sine. You're gonna have to say cosecant of 49 equals, call this C over 3. Now, cosecant is the reciprocal of sine. Okay, so I can say it's 3 times, if I want to, 1 over sine of 49. So that in a calculator, since there's no cosecant function. So in my calculator, I type 3 times, and then make sure I'm in parentheses. Make sure I go 1 divided by sine of 49, close parentheses, twice. Make sure that gets done, and I'm going to get 3.97, 3.98. Should be. Okay, so to find the missing side here, I again use my Pythagorean theorem. 0.98 squared equals a squared plus 3 squared, which is 9. I'm going to take 3.98 times 3.98. So that's going to be 15.84 minus a 9 equals a squared. That's 6.84 equals a squared. So we'll take the square root of that. Gives me 2.61. So a equals 2.61. And to find the missing angle here, that's going to be 180 minus 90 minus 49, or 90 minus 49, which equals 41 degrees. So we now solve that right triangle. And we can always check our values if I want to. If I take 3 squared, if I take 2.61, which is going to be if I take 2.61 times itself, I do it the hard way. You can square it if you want to hit the square button. And then I'm going to add 3 squared, which is 9. Take the square root of that. Okay, 15, round at 15, it's going to be close with round and 15.81. Take the square root of 15.81. I should get about 3.98. Checks out. But because this is a reciprocal, not an inverse, but a reciprocal function, we're going to have to use 1 over when I do cosecant. Do not get inverse trig functions confused with reciprocal functions. They are different things. This concludes my tutorial on solving right triangles.